Welcome to Maths and Science by IITian channel. From this channel, now I will be taking up a very crucial topic in rotational motion, which rigid body and rotational motion is the concept on which we have been driving towards the subject, and almost more than 10 to 15 lectures have been completed on the rotational motion. Now, in this particular lecture, we will be taking up a conical pendulum and derivation of time period for a conical pendulum. In regular kinematics, you might have seen, and application of Newton's laws, you might have already known about the simple pendulum. Simple pendulum oscillates in the vertical circle, whereas conical pendulum moves in the horizontal circle. When a mass m makes motion in vertical circle and when a mass m moves in the horizontal circle, what will be the difference? Both masses are hung by a string of massless string of length L, and the angle from the vertical for simple pendulum it changes, whereas for conical pendulum it is, while in the motion it is fixed. Conical pendulum theta is fixed. For simple pendulum theta varies. For simple pendulum we all know that time period is equal to 2 pi into square root of L by G, which almost everybody might be aware of this. Now we will discuss the difference between a simple pendulum motion and a conical pendulum motion. It is in the horizontal circle, it is in the vertical circle, and the time period for a conical pendulum is 2 pi into square root of L cos theta by G. Here cos theta is fixed, whereas in simple pendulum theta is not fixed. Theta is varying with the motion of the with time while the pendulum mass is in motion in vertical circle. Now let us derive this expression. Why I have taken up in this lecture of rigid body motion? Because this particular conical pendulum is a mass m making a circular motion in a horizontal plane. Circular motion in a horizontal plane. Hence, it can be taken up for the rotational motion of a mass. Hence, I have taken up this conical pendulum in this series of lectures. Now, question is derive and compare the time period T of a conical pendulum with simple pendulum. Let us, as I have already explained, conical pendulum, the circle is a vertical circle, whereas for the it is a horizontal circle for conical pendulum. For a simple pendulum it is a vertical circle, like in a vertical plane. Now, in a conical pendulum moving in a circular path like this, making an angle theta, the main force for balance of this motion, you know, for a circular motion, what are the main forces? For a circular motion, the main forces are, one is tension in the string, another is, this is string tension, and another is centripetal force. Tension in the string, if it is like this, tension in the string, please forgive me for the diagram, tension in the spring here and centripetal force like this. Now, here in simple pendulum what happens? Angle varies, and for small angles, remember this, less than 15 degree, angle should not be more than 15 degree. For a higher value, sin theta changes. Less than 15 degree, T is equal to 2 pi into square root of L by G. For less than 15 degree, that you please remember. I have taken this value from the literature. You can also review it. If there is any slight change with the latest literature, you make that amendment. But approximately it is about 15 degrees. But here in conical pendulum, angle is fixed. It moves with constant speed and L is also fixed. Here the tension whatever is there, horizontal component of this tension. This tension is here. The horizontal tension is this way. The horizontal tension and horizontal centripetal force makes this to make circular motion in the horizontal plane. Horizontal tension. Now, we have to derive. The first step, Here in simple pendulum, as far as energy is concerned, let us make a note of it also. Potential energy and kinetic energy interchange during motion, during movement. That means, for example, in a simple pendulum, initial position is this, second position is here. Then what happens? This position is at a higher elevation when compared to this. Let me say this is position 1, position 2, this is position 1, initial position, this h1 to this height, then potential energy increased from delta PE is equal to mg into h2 minus h1. This is the change in the potential energy. If h1 is taken as a datum, then potential energy, if it is treated as 0 at the datum, then it becomes change in potential energy mg h12. This is h2, this is h1. h12 is the difference, mg h12. This mg h12 is a gain because it is moving upwards. The height is positive, hence there is a gain in the, when compared with the datum, there is a gain in the potential energy. Then what happens to kinetic energy? Kinetic energy will be reduced when potential energy is increasing, because kinetic energy plus potential energy is equal to constant as per conservation of energy rule. That means in a simple pendulum, the movement is energy driven and periodic conversion. Initially kinetic energy is, potential energy is high, it is moved from here, a position of O, potential energy is high, it is converted to kinetic energy at the bottom, at the datum, highest kinetic energy, again it moves to the position 2 where potential energy increases and kinetic energy is reduced. That means conversion of potential energy and kinetic energy for keeping the conservation principle of energy intact, conversion of potential energy and kinetic energy takes place during motion. Then let us talk about conical pendulum. Why I am giving this brief? Because if you know the concept clearly, what is a conical pendulum and why it is important, and what is a simple pendulum, what are the driving forces for it, then you will appreciate the derivation. It's a lecture on physics, so that let us see the science behind it, action behind each and every equation. In case of conical pendulum, what happens? Conical pendulum, it is moving in the circular motion. This is also L, this is also L. There is no potential energy conversion because it's a horizontal circle. Please try to understand. It's a horizontal circle. As I shown in the first, you see, it's a horizontal circle. This one is a horizontal circle, whereas it's a vertical circle. In a horizontal circle, there is no potential energy gain, there is no potential energy loss, because it is in the horizontal plane and there is no height change for the mass. Hence, we can say mechanical energy is constant, no oscillations are taking place, it is only moving in the horizontal circle, horizontal rotational motion. Whereas simple pendulum is oscillating, it is coming from here, going back, it is oscillation. Whereas there is no oscillation, it is constantly moving in the circular path. Here, by mistake I have written here L, it is not L, length of the string is L. Now, in a horizontal circle, when it is moving, it moves with constant speed, we are assuming, and constant height. Now let us go for solving finding the T for this particular case. Length of the string. Now let us go for the solution to find T. What is length of the string? Is equal to L. Radius of the horizontal circle. This is the radius of the horizontal circle. Radius of horizontal circle, because it is making motion or movement in the horizontal circle. Radius of the horizontal circle will be opposite side by hypotenuse is equal to sin theta. Sin theta is equal to R by L. I have many times explained in my trigonometry classes also. Please see my vector lectures and trigonometry lectures, and I have taken out a short also on trigonometry functions. Please see that YouTube short also, and please see that sin theta, please understand that sin theta is equal to opposite side by hypotenuse, that is R by L. Then radius of the horizontal circle is equal to L sin theta. Do you agree? Then we have already told that there will be a tension in the string. Let this be the tension in the string T. T will have a vertical component. These components I have already explained you in T vertical and T horizontal in my vector classes. Please see the vector lectures on vectors from my channel, and you will understand. And on forces also, first class, first lecture in physics from me was on forces in a truss. What is tension, what is compression, how to take out the components. You can see that lecture also from my channel, Maths and Science by IITian. Same, this channel only. Please subscribe to my channel and see those videos. You will understand. Now, tension in the string. We have seen, I have drawn these two circles. I have shown you, this is the tension. When tension is there, the horizontal component of the tension, to be taken into consideration. Vertical component will not have, this is let us say TH, any effect on this motion, because there is no vertical acceleration. This object is not moving in the vertical direction, it is only moving in the horizontal circular direction. Hence, we will consider horizontal motion. That particular horizontal motion is countered by the tension in the string in the horizontal is countered by the centripetal force. What is that? Horizontal component of tension TH is equal to horizontal component T into sin theta. T is here, this is T sin theta. This is equal to centripetal force for equilibrium to be maintained. What is centripetal force? You know very well from your basics. Centripetal force is equal to mr omega square. Please remember this. In a circular motion, it is mr omega square, which I have explained in rotational motion initial lectures. R, you know, radius of the circle, this is equal to mr omega square. That implies T sin theta is equal to m into what is R? R we have derived here. R is equal to, somewhere we have written what is the value of R. R is equal to L sin theta. ml sin theta into omega square. Then T is equal to ml sin theta omega square, this is TH. And what is TV? TV is equal to vertical component of tension. We are not talking about the vertical acceleration. There is no acceleration in the vertical direction, but tension is there. TV is equal to T cos theta. From these two, dividing one by the other, TH by TV, that is equal to TH by TV, T sin theta divided by T cos theta. TT gets cancelled, it will be tan theta. This tan theta will be equal to TH by TV is equal to this T cos theta is nothing but, it is countered by which force? This is countered by mg. Vertical gravitational pull towards the center of the earth. This is what I have explained in the forces when you resolve the forces in different directions. This is equal to mg. Now, TH by TV is equal to, what is that? ML sin theta omega square divided by TV is equal to mg, so that get cancelled. This will equate it to tan theta, because TH by TV is equal to tan theta. Ultimately what we have got is sin theta omega square by L into sin theta omega square by G is equal to tan theta. Let us try to solve it. L into sin theta omega square by G is equal to sin theta by cos theta. Can we cancel sin theta on both sides, so that it gives the answer 1 here? Then it implies L omega square by G is equal to 1 by cos theta. That implies L is equal to L cos theta, omega square is equal to G by L cos theta. That means angular frequency, that is equal to angular velocity, is equal to square root of G by cos theta. This is one of the most important derivations in case of conical pendulum. Conical pendulum. But here we have to find out the time period. What is the relation between the time period and omega? Omega is the angular velocity. For a circle having 2 pi radians, how much time it takes is the time period. So, T is equal to 2 pi by omega. Please remember this. It is a very important equation. For 2 pi radians, for a circle, when there is an angular frequency or angular velocity omega is there, time period is equal to 2 pi by omega. Very important equation, applicable in quantum physics. In almost all the physics applications it is applicable, even including engineering, physics and higher level physics. T is equal to 2 pi by omega. Now we have to find T. What is omega? Square root of G by cos theta. Therefore, substitute that value in this. 2 pi by square root of omega is G by cos theta. Not G by cos theta, L cos theta. G by L cos theta into L. That gives T is equal to 2 pi into square root of L cos theta by G. This is what was required, this is what we have got proved. Whereas it is for conical pendulum. For a simple pendulum, the motion is not horizontal, it is in vertical plane, it goes 2 pi into square root of L by G. It has theta restrictions. Theta should be less than 15 degrees. Whereas for a conical pendulum, there is no theta restriction. Here we will have some conclusions. Conical pendulum. Some good conclusions let us have. It is not only that physics, a formula to be derived, to be understood. L cos theta by G. If theta is equal to 0, then T is equal to 2 pi into square root of L by G. It is like vertical motion. Two, if theta is equal to 90 degrees, T is equal to 0, because cos 90 is 0. It's in the horizontal motion. R is equal to L, horizontal circular motion, without vertical components. Horizontal circular motion. It is vertical motion. When theta is equal to 90 degrees, we have understood. When theta is equal to 0 degrees, we have understood. We have understood about the simple pendulum. We have understood about the conical pendulum. If there is a value addition to your knowledge because of this, please share my channel details and share my videos and subscribe to my channel Maths and Science by IITian, and in the next class we will do some typical little bit tougher examples, numericals. Next class on rigid body motion. It's a big ocean. Somewhere we have to stop. Maybe after 2-3 classes I will stop rigid body motion and I will go back to the Newtonian motion. Newton's law, laws of motion, or kinematics. Whatever is preferred, please give it in your comments. Either kinematics, you want kinematics means I will go for kinematics. If you want Newton's laws means I will go for Newton's laws. Before going that, I will little bit give introduction about the Lagrangian equations of motion. So that Lagrangian equations of motion are more simpler when compared with the Newton's laws of motion. Concepts are same, but methods are different. So that in the competitive examinations you can use Lagrangian motion and solve the problems with ease. Where forces are not considered, only the energy conservation principles are considered. On the basis of energy, energy is a scalar. Whereas force is a vector. In Newton's laws of motion, force is usually used, and it is, if some people may feel it is tedious to resolve the vectors, in that case we will go for Lagrangian, where energy is a scalar product, so that we can have some comfort in Lagrangian. But some people may prefer Newton's. That's up to them. Best of luck to everybody. Thank you for listening to me. Thank you.